All right, we're back at Build 2017 in lovely Seattle. We're going to talk to Brendan Burns. And
right.
Brendan, we're going to talk about Kubernetes and blah, blah, and Cloud Shell.
Sure.
Quite interesting. They're related.
They're related?
But I want to talk about containers too.
All right.
I mean,
Right on.
containers, they've been the buzz for quite some time now.
Yeah.
Docker, et cetera, et cetera.
For sure.
But I kind of want to dig in. And the first question I'm going to ask you is, what's the difference between a container and a library OS?
And a library.
Library OS, where you strip everything that
Sure.
you don't need, and you have only the parts that you need, and then things can work.
I mean, I think one of the differences there is that you also have resource isolation with a container. I mean, actually, honestly, I feel like container is kind of, it's one of these words that everybody has a slightly different meaning, because some people are talking about, we're packaging our application. We're packaging our configuration files, we're putting it all in that container image, deploying it to a registry, makes it easy to distribute that container image. They're really focused on the development deployment parts of being a container. Some people are really interested in how many can we pack onto a machine? How can we drive up the utilization really high? That sort of thing. So I think, and really honestly, you should be thinking about all of those things. And then I think also it got kind of conflated with a bunch of people who are like, this is going to transform how I build applications. And it's like, yeah, it's useful. I mean, definitely you can use this to transform, but it's not just using it isn't transformative. You have to actually understand how it's supposed to be used and things like that. So I think container by itself is this word that means a lot of different things.
Understood. But I mean, in some sense, is it like a DLL?
Yeah.
Remember, a DLL is a container, a functionality.
Yeah, I guess so, yeah.
You think of it that way, and you can compose.
A container is bigger. I mean, I think a container definitely has this notion that it's associated with an application. It is an encapsulation, it's an object that represents one application, right? So it's more than a DLL. And in fact, in some ways, it's actually trying to move away from DLLs, because it's very explicitly wanting to put a boundary around you and all of your dependencies.
Okay.
And you carry them with you.
Understood.
You don't depend on any system dependencies. You don't depend on any DLLs in the operating system. Because when you do that, you introduce this coupling where, I really want to upgrade that library, but I've got 6 different applications that all depend on that one library, and if I upgrade it, it affects them all. And so you really don't want that situation where I'm afraid to update application A because it might affect application B, C, or D. And that's where a lot of outages come from.
Understood.
Is where you have unintended consequences. You know what an upgrade of application A is supposed to look like, but you don't realize that in doing that, you're going to take out application C, right?
Understood.
And so breaking up those dependencies is a big part of what containers are all about.
And a container basically has everything the app needs to run.
Everything that the app
thinks
needs
it's on an operating system.
Everything that the app needs to run except for the kernel. And then the kernel is the shared foundation that all these different containers run on top of.
Interesting.
Yeah.
Very cool. Because I know there's a company that builds an operating system out of containers.
Right. Yeah. No. It's turned out. I mean, for a long time, we had all of these package managers. NuGet or apt on Linux, that are all about imperatively installing all these different pieces, and they know about their dependencies. If you need that, you need this library and this DLL and all this sort of stuff. And what it's turned out is that it's actually easier to just distribute a whole container. Don't worry about trying to understand the dependencies of that application. Just package them all up, put a bow around it, and tell people here, this is the way you install software. There's nothing on the OS but the kernel. Everything else you want to install is just a container that runs on that kernel.
Awesome, man.
So, yeah.
And it makes updating incredibly easy.
Makes updating incredibly easy, makes consistency. You don't have to worry about is it what version of the operating system, what flavor of the operating system. You always know the thing that I ran on my laptop works exactly like it should when it's deployed on your laptop or even up into the cloud. That's a hugely powerful thing.
Excellent, man. So Kubernetes, let's talk about that.
Sure.
And then we move into Cloud Shell.
Sure.
So tell us about Kubernetes.
Tell us about Kubernetes.
Hey, by the way, is there anybody out there? Are you
anybody
watching?
out there? Anybody
Are you
watching?
asking questions? Ask your questions about containers.
Anything you want to talk about with containers,
Kubernetes and Cloud Shell.
Cloud Shell, anything you want to know.
Ask, communicate.
So, Kubernetes, I actually have been using containers for a really long time, almost a decade at this point. And Kubernetes really came out of a lot of my own personal experiences building and deploying reliable applications. And as Docker and really popularized the idea of a container, they were really popularizing an idea about how you manage, package and deploy your software, but really onto one machine. And it was very clear that you need this software that's going to orchestrate deployment onto a bunch of different machines. Indeed, really allow you to forget about the machines. And that's really where Kubernetes was born from. And it was very clear to me and to the other people who I started it with that it had to be open source, right? It had to be, infrastructure was becoming open source, right? It was becoming this thing where if we didn't build a community around it, if we didn't rally a bunch of different people to come to it, it wasn't going to be successful. You couldn't just sort of, build something that you held inside your walled garden. And that has actually truly been, I think, the biggest thing that has been awesome to see is that community of people around the world who have come together to help build this thing. We've had over 1,000 people contribute code or documentation, and thousands more. In fact, tens of thousands of people who hang out in our Slack channels and help people out with questions and that sort of thing. And just that sense that we're all building this software together has been a really amazing
That's
thing.
Incredible. And look what you've done.
Yeah, it's been cool. I mean, I really hate it when people say that because look what we did. Like,
when I say you, I'm talking the metaphorical.
Yeah, exactly, right? Exactly, because it really is a community effort.
Totally understood. Yeah. But somebody had to kind of initiate.
You got to throw the
kernel,
pebble, right? It's like you throw the pebble and you have no idea the tsunami that's going to land and when it hits the shore.
That's a beautiful thing.
Like, it's amazing.
So, let's talk about Cloud Shell.
Sure.
And what is the relationship between Cloud Shell and Kubernetes?
So Cloud Shell uses containers. Every shell that you run is a container, and those containers are being deployed and managed by Kubernetes. In the case of Bash, it's Kubernetes running on a Linux machine. In the case of PowerShell that's coming soon, it's going to be a Windows container running on a Windows machine, but still orchestrated through the same infrastructure, the same APIs. And I think that's another really powerful thing that people are finding is they're doing these hybrid deployments. Some of their application is built in .NET, some of their applications in Node.js. They're deploying to Linux, they're deploying to Windows. By using the container as an abstraction, it can be consistent across both those operating systems. By using a container orchestrator that can deploy to all those environments, they can have the same management software deploy an application regardless of what operating system it happens to be running on. So that's pretty powerful.
It's super powerful.
Yeah.
Now, let me ask you something. I've not looked at the source code for Kubernetes.
Yeah.
Or containers, for that matter.
Yeah.
Let's kind of geek out a little bit there.
Sure.
I mean, what language, what are most of you guys coding in?
It's almost entirely Go, actually.
Wow.
So if you look at Docker, Docker's all Go. Kubernetes is all in Go. So that's really kind of, I think, been and become the system language of choice for these kinds of infrastructure systems lately.
Why is that?
I don't know. I mean, I think it has a lot of positive things going for it in terms of the ease. I was just talking about how easy it is to cross-compile it. So, you can build binaries for Linux on x86, Linux on ARM, Raspberry Pi, Windows on both x86 and ARM, all from one command install. No special extra tools to install, nothing like that. You just flick a flag and you're building for Windows, you flick a flag, you're building for Linux. That's hugely powerful. I think there's a certain amount of once enough of people start doing it, it just becomes the de facto thing to do. We really want to build these open source communities, and so choosing a language that the community is kind of using helps, in other projects, helps kind of build that community in. It became sort of why wouldn't you at some level?
Sure.
It kind of feels like C. Go is I feel like it kind of feels like a modernized C.
Interesting.
Like a C with a standard library and a garbage collector. You get. I think every language has its sort of niche and has its thing that it's powerful for.
Sure.
And this happens to just kind of be a sweet spot. I wouldn't want to write web applications with it.
Okay.
Right? HTML generation and all that handling is really bad. It's just their libraries aren't there. But if you want to write RESTful APIs, you want to write system infrastructure, it's a great language for that.
I agree. I've been playing around with it a little bit with Chaos Monkey.
Okay. Yeah.
Which they shipped version 2. It comes with Spinnaker. They wrote Chaos Monkey and Go.
Yeah.
Hey, will he speak to Cloud Shell? Of course he will speak to Cloud Shell, which is sort of, we wanted to start with containers, then go to Kubernetes, then go to Cloud Shell. Now he's going to explain that. But first, let's ask a question.
Sure.
So Dan wants to know, are multiple container kernels needed? Different versions? Are container technologies OS specific?
So generally speaking, multiple kernels are not necessary. It's not 100% true. It's like when people say like, compile once, run anywhere. Like it's like, well, mostly, right? And so in general, like if you're using the common kernel functionality, if you're not out on the bleeding edge, if you're not really, really old software trying to run on a new kernel or vice versa, it'll generally work. Like within sort of a couple years, within those sort of versions, if you're not really out on the bleeding edge, it'll work. Okay. If it's OS specific, it's definitely OS specific. You can't take a Windows container and run it on Linux, and you can't take a Linux container and run it on Windows. It expects the underlying kernel to be that operating system kernel. But I think the bigger point, though, is that all of the higher level APIs, all of the APIs for building that image, for pushing that image, for downloading that image, for managing it in the container orchestrator, those are the same. And so like that means that all the tooling can be the same and all of the deployment infrastructure can be the same. And I think that's the important part. More than the operating system that you deploy to, it's that the tools that you use to build and deploy can really be unified.
And you just expect the fabric to be there.
Exactly. You come to expect that it's just sort of there.
Absolutely.
Yeah,
all right, so let's speak to Cloud Shell. Really cool demo today.
Yeah. Super excited about it.
You mentioned that it's running in a Kubernetes container.
That's right.
If we're doing Bash, it's Linux.
Yep.
Correct?
That's right.
I mean, obviously.
Yep.
Or wait, it could be Windows subsystem, right?
It's not though.
I mean, I've been playing around with that. That's why I had to bring it up. It's quite interesting, the things you can do in there. I was impressed.
No, I love it. You can actually build Kubernetes within the Windows subsystem for Linux now with Windows 10 Creator Update. You can do it. So
that's awesome.
It's pretty cool.
That's very cool.
Yeah.
All right, so let's do a demo of Cloud Shell, shall
absolutely.
we?
Yeah. So I have here the Azure portal, and now we're in the midst of rolling it out worldwide. So if you open up your Azure portal, everyone should see the Cloud Shell icon. When you click on it, if you're in the lucky few, it'll pop up and it'll be working. And if you're in the unlucky few, in the next day or so, it should roll out to you. So we're in the process of making sure we do a stable rollout of this thing. But my account happens to be turned on.
Okay.
So we click on the Cloud Shell here. And now what's going on in the background as this comes up is we're actually out there provisioning. It says it's requesting a Cloud Shell. It's provisioning that container. And now at this point, that container is up and running. And we're connecting up the terminal so that we can interact with the Cloud Shell.
Cool.
So we will, cross our fingers. The demo gods have been pretty good to me so far today. So I'm going to keep my fingers crossed that they continue to be good to me today.
Well, you are on wireless.
I am on wireless. That's always and I'm on battery power too. So those are both kind of dicey choices that I'm going to make.
It's okay.
I will at this point out that it's in public preview. Right?
Yes,
so not
but the demo gods will be good to us. You know why? I'm wearing glasses.
You're wearing glasses?
You're wearing glasses. We're good, man.
We're good. We'll keep our fingers crossed. If not...
Hey, Steph, dial up the internet speed, man.
Yeah. Okay. If not, the team that I know that works on this, I'm going to have to go back and have a chat with them.
Yeah. Hey Scott, this is for Scott Guthrie. Look, the cloud needs to work without the internet.
See?
All right.
There we go. We're there. All right.
Let's do it.
So what's really awesome about this, actually, two things. One is we got the new AZ CLI 2.0.
Yep.
We didn't have to download anything. We didn't have to install anything. You could do this on your iPad or any other tablet, any other device. And also, we don't have to log in. It's grabbed all of the authentication credentials from the web that our web login that we already have there. So it's a really, really seamless experience.
Yep.
And we're integrating that as well with our docs. So when you're in the middle of going through a walkthrough of here's how to use Azure, you can launch up this shell and just start typing away and running those commands inside the docs themselves, right? So I can actually start, I can say AZ, there we go, if I get in here, right? I've got a little bit of lag here. I apologize for that. ACS list. Yeah.
That's interesting.
That's the Wi-Fi for you right there. That's what that is. 2. This will be a quick demo. All right, so when I do that, this is going to actually go into the ACS API, the Azure Container Service API, and it's going to list the container clusters that I have available to me. And so there you can see coming back, there's actually that Kubernetes cluster that I provisioned earlier for one of my build demos showing up here in the AZ CLI. So really anything you want to do with your Azure account, you can do in the portal, and it immediately shows up in the UI, right? So I could, for example, do AZ group create equals stage 9, location equals East US. If I wait for a second.
Okay.
Lag. All right, there we go. And if we run that, this is going to create a resource group, just an empty resource group, and it's up and running. But now if I go back over here with my resource groups and I hit refresh, I can minimize this down here, and there's that Channel 9 research group that we just created. So I think that this was one of the intuitions behind the Cloud Shell, is that, for visualization, the web is great. But if you really want to just kind of pound out creating some stuff, run some scripts, do some actions to create new VMs or anything else, having that terminal there just really helps you be a power user. And along those lines, if you are more familiar with something like PowerShell, you have that available to you as well. So whatever the flavor of terminal and scripting you're used to, you can use inside this web interface.
It's great.
Yeah.
It's super productive.
It's awesome. I mean, I'm very excited about it.
Great, good job. How did the idea come about? Like, was it based on user feedback? I mean, or did somebody just have a good idea?
Well, I think it's a little bit of both. I think one of the things we've had in Kubernetes for a really long time is this CLI, kube control exec, that allowed you to get a shell into your running container for debugging mostly. Like, that thing's not working right. I can get in there, poke around at the file system, see what the web server's doing, that kind of stuff, right? And so it was kind of a logical extension of that.
Okay.
Like, why not, take that experience and do it for the CLI? I'll admit it was also part of my own experience, downloading and having to, some of the things you talked about installing software. Like, it's a little bit of a pain point, right? It's a little bit of a hurdle to get over. And so thinking about how can we streamline this, make this as easy as possible for someone to get from zero to working with the Azure cloud. I think that honestly, we're at our best when we kind of are not in the user's way, right? When it's smooth and easy and they don't even at some level notice that we're here, they're developing their applications productively, and I think that's sort of part of the intuition as well.
Beautiful.
So, and we put together a little video. Actually, the original one was totally hacked together, but we sort of showed the concept, got it pitched, and got it built, and in about 6 months, actually. So it was one of the fastest projects I've been on, from like initial demo hacky pitch to out in the public. It was just awesome velocity.
Nice job, man.
Yeah, it was very cool.
Bash
And I should really say, again, as with the group, there's a team behind this, and so I really want to shout out to that team. They did a lot of hard work.
All right, so from here on out, when I say you, I'm talking about the team.
That's right, all right.
Okay.
I just really want to make sure.
No, I'm with you, man.
They get mad at me,
That. No, but I think it's good it shows your good nature.
Yeah, that's right.
Mario wants to know, actually Coded J, who's been up there for a while, is Cloud Shell Bash customizable just like terminal and local machine?
So you do have a home directory, and it's a persistent home directory. And so you want to drop a bash RC, you want to drop other kinds of initialization files, Bash will find those and customize it out. So yeah, or even like, you have some files that you're working on and you close out your web browser and you come back, you can have that session restored to you. The session itself goes away, right? So like you might lose your command line history, but the files that you played around with, configuration files and whatnot, they'll stick around.
Cool.
Yeah.
Mario, what container system would you recommend for a beginner?
None of them. No, we talked about actually this. We talked about this in the session that I did today. I think they're all still too hard, right?
Okay.
I think we're at this place where, if you've done a lot with containers, orchestration makes sense and you sort of work with it. But honestly, I think that we have a lot of work to do from the container up in providing these rich development experiences that just make it easier for you to get started with a container. And actually, apropos of that, we demoed something in our session today that I can actually show you here. Sadly, it's a screen cap because the guy who did the demo was the former CTO of Deus, who we acquired. He did the demo on his laptop. I don't have it set up on my laptop, but I do have the video of him doing it, so I can walk us through that here. So this is a project called Draft that we're working on. The basic idea here is like I have a very simple Python app.
Okay.
Right, simple Flask application. I'm really just a developer. I could run this on my local machine, But now I say draft create, and what draft has done is it's detected a Python app, and it's scaffolded in a bunch of files, Docker files, deployment files, that enable me to containerize without even really understanding that I'm using a container. And now I say draft up, and you can see here, this is the container building. But again, although you're seeing the container build, you yourself haven't had to learn anything about Docker. You haven't had to learn anything about how to configure all these build files. Draft is sort of heuristically taking care of that for you, right? And then at this point, it's watching the local file system. This thing has been deployed out to a Kubernetes cluster. And when I curl that, I see hello draft, right? So this code that was on my machine has been deployed to the cloud with these 2 commands. That's it, right? And now actually I'm going to change my application from draft to hello Azure.
Okay.
And I save that, and what's going to happen actually is we have a little daemon run locally that's monitoring the file system. It detects that change, automatically triggers a build. Once that build is done, it actually triggers a deployment, and that new code that I was writing on my laptop is again deployed out to the cloud.
Nice.
Right, and so like we're giving you that inner loop local development experience, except for your cloud, your code is no longer running out on your laptop. It's running in the cloud. It's ready for other people to hit it. Now, obviously, we really don't think that this is a production kind of scenario, right? This isn't something that you would use to take your app all the way through to production. Good CI/CD systems, Visual Studio Team Services, those are the kinds of tools you want to use if you have multiple developers. We can shut down this demo.
Okay.
You know, if you have multiple developers collaborating, you need version control, you want a real pipeline that runs tests and stuff like that.
Sure.
But for that person who's asking that question, how do I get involved with containers? How do I first play around with it? I think tools like this are really going to be the way they start to understand how these things start coming together.
Sure, and I mean, the other thing is, like, they have to know why they want to use containers in the first place.
Right.
Right, I mean, containers might be super cool and they're
Yeah,
great.
yeah.
It's the most wonderful thing ever. I mean, you have your definite bias towards that.
Yeah.
It totally makes perfect sense, but you also need to think through, why do I want a container?
Yeah, exactly. I think that's really important.
So Aaron, can you tell us more about the level of isolation we get with Cloud Shell?
So I will tell you that we have made sure that it is multi-tenant secure, which means that we understand that there are not nice people out there in the world, and if we make a service available to everybody, people are going to come in and try and attack it. And so we've worked with a variety of people who are security experts. I actually work with Mark Rusinovich a lot, who's a really great guy on security.
Yes.
And just to ensure that any user's space, files, running processes are securely isolated from any other user's secure processes.
Absolutely.
So, and I would say along those lines, we really don't believe that the container itself is a security boundary. And we've said this repeatedly, Mark has said this repeatedly, you have to have a hypervisor in the mix.
Absolutely.
Like the container's great for resource isolation, making sure the intern's Minecraft server doesn't interfere with your production web server. But if you have people who you don't trust on your system, there's really nothing but a hypervisor that can help keep you secure.
And thus security virtualization.
Right, absolutely, right. So I think you can still have that container experience, and so Hyper-V containers are one of those things. They're trying to give you that container developer experience, application-oriented experience, but also include the security that a hypervisor can provide.
Cool. So one of the question that I have for you is, I mean, how far does the rabbit hole go down? And in some sense, let's say I want to build a non-trivial system,
right,
which of course most
we do.
People do.
Yeah.
And I actually want to have a fair number of containers, and I want to have a lot of intra-communication between various containers. I don't care if they're running Linux or they're running Windows.
Right.
They have endpoints they can communicate.
Right.
And get into each one.
Right.
So I want to build this fabric that's relatively complicated. It's going to be compute heavy.
Right.
And it's going to be doing a lot of interesting stuff. And
right,
each thing is not a microservice.
Sure.
But it's specifically, this container does these things really well.
Right.
How well do you scale? How well has it been proven that this technology can really weave into something that's not trivial,
right,
but really complicated?
Yeah, I mean, I think that, just in terms of raw numbers, I think we have the scale to handle the largest applications, thousands of machines, tens to hundreds of thousands of containers.
Okay.
But I think that the more interesting question there is actually the cognitive complexity, right? It's not so much deploying everything, it's managing and understanding everything. Mm-hmm. We have some tools, namespaces and other things to kind of organize stuff, but I think that this is still a really open question. I think that in many ways, in switching to the cloud, we've lost the best development environments that we had on the sort of like single machine, IDE, Visual Studio kind of experience. Like in that move to the cloud, suddenly all this complexity has come in, and I think that development environments haven't quite kept up. And so actually one of the most exciting things I feel like working on over the next year, and a bunch of these little projects are part of this, is trying to figure that out, working with the people who work on Visual Studio Code. I've been writing Visual Studio Code extensions around this, just prototyping and trying to figure out, if I'm deploying a microservices-based API with all these different services and how they interact, how do I understand what's going on? How do I, when something goes wrong, like it's great when it all works, but when it goes wrong, like how do I know which piece? And or if I'm just a developer and I'm doing one little service in this big soup of other services, how can I like mostly use production, but have my requests route to my developer instance of my little service and then back into the production services, so I don't have to, I can't run the whole stack on my laptop.
Sure.
Right? I need to run mostly it in the cloud, but still have those routes come back to this thing that I'm developing locally. I think those are all really interesting questions that we need to explore. I think Microsoft, with their heritage in developer experience and developer productivity, is really the ideal place for this stuff to come out of.
Absolutely.
So I'm really super excited to see how we build those things together.
And there's definitely a place for machine learning.
Yeah, I think absolutely. I think there's a
Sentinels.
Yeah, well, not only that, but even things like, I think auto scaling is great in the immediate sense. Like we can have control loops that say like, oh, your load's going up. But what about the thing that figures out like, you're running the back end for a TV show that shows on Thursday nights, right? We should be able to figure that out too and say like, oh, it's 6 p.m. on Thursday night. We should probably start scaling you up, because every single week at this time, you get scaled up. And that's the kind of thing that machine learning can tell you. Another really interesting part of it is resource limits. So when you're deploying these containers, you have to say, how many cores do you want? How much memory do you want? It turns out people are terrible at this, right?
Yes.
And they always overestimate. And when you overestimate, you leave CPU on the ground, right? Like you say, I can't give you, if you've asked for a core, I can't give that core to anybody else. And if you only use 1/10 of it, well, like 90% of it is wasted, right? So wouldn't it be much better if I could look historically across your usage patterns and say, you know what? You said you needed a core, but every other time in the past history when you have run this application, you've only ever used 1/10. We're going to scale you down. We'll scale you up if you need it. Something changed, but we're going to learn, maybe even across your organization, that web server never uses more than a core. No matter how much it's Node.js maybe. Node.js really can't use more than a core. Sure. No matter what anybody asks for, don't give it more than a core, right? And those kinds of machine learning applied to patterns of application behavior, I think really can enable people, again, to deploy their systems more reliably and more efficiently without them thinking about it. I think that's the end goal at the end, is that like you should focus on your app and let Azure take care of the rest.
Amen,
right?
man.
So.
And that's been the mantra of things like .NET and the IDE in general for years. So, Jane, as a member of a company with different Azure accounts for different devs, can we use Cloud Shell to interact with other Azure accounts?
You can use it to interact with different subscriptions. So like when you're in the Cloud Shell, you're you as a user, a particular Microsoft ID. So you can't use it for multiple Microsoft IDs, but for that Microsoft ID, if you have access to multiple tenants or multiple subscriptions, you can use it just like you could on your local desktop.
Okay.
Right? So it won't allow you to do like multi-user login, but it will allow you to span across different subscriptions, even different companies.
Sure.
Yeah. So,
and maybe the different developers have different resource groups.
Right, exactly.
As well.
Yeah, exactly.
Cool. Thank you for asking questions. Keep them coming, unless I only have 30 seconds left. 1 minute.
1 minute.
So
all
1 minute. That's cool. Let's talk about I love where you the machine learning aspect and actually just making the systems self-aware.
Yeah.
But let's talk about realistic in the next year.
Right.
Where are you going to take this? Where do you see it going?
So I think right now where we're going is turning increased management. Auto scaling your cluster, really making it so that you don't think about running the infrastructure. You run the container orchestration API is just there for you to consume.
Yep.
You still see VMs. You still the container APIs are there, but there's still a lot of other stuff that's distracting that's present. I think trying to ensure that if all you want is a container API, that's the only thing you need to think about, is a big part of what we're doing. As well as a lot of this upstream, how do we build better developer experiences? How do we build integration with development tooling, all of that sort of stuff. And then obviously just being good open source citizens and working in the community, making contributions upstream, all of the docs, everything else that you do to keep that community running.
Excellent, man.
Yeah.
And so one last quick question I would like to ask is,
Sure.
what sort of things can I do to a container-based distributed system that could essentially do what Chaos Monkey does?
Sure.
Which, is sort of a heavy hammer. It shuts instances down.
Yeah.
But it would be kind of really interesting to vet my resiliency as a developer.
Yeah.
Like, I want to be able to do that.
Yeah.
I want resiliency tests. I want to do experiments.
Yeah.
How would I do that in a containerized world?
So there's actually a Kubernetes Chaos Monkey that's out there. Like you can it's not the Netflix, it's not the famous one, but somebody in open source world built it.
Beautiful.
Talks to the API, it deletes things, it does all the things you'd expect it to do. In some ways it's actually easier because that API is application oriented. Right? So like if I just want to delete one instance of your web server, I just find your web server, I kill it. The funniest thing though I saw, if you really want to take the Chaos Monkey thing to the extreme, somebody actually built a first-person shooter. So you could run around your containers and you could shoot your containers and they would die and then come back. So you can be your own Chaos Monkey.
Excellent. Well, I would like to I'd actually have an ape do that for me.
Oh, see,
the ape would play the shooter game.
That's right. All right, perfect.
Hey, thank you so much. Really pleasure to talk to you, man.
Thank you so much.
There's a lot more that should be dug into.
Absolutely.
And everybody should check out Cloud Shell.
Definitely do it.
NPM packages can be installed globally in Cloud Shell?
Locally inside your directory, not globally inside the system.
Thanks for all the question coded J and people.
All right, awesome. Thank you, guys.